Good evening. My name is Dan B, and I am here, G4V guitar instructor, here for the Guitar for Vets Workbench. Every good guitar store has a technical and repair section. They provide services from changing strings and cleaning, some repairs, as well as performing setup and modifications on your guitar or guitars. Those services are not free. There are guitar maintenance skills that you yourself can learn to perform on your guitar and save you some money, a boatload, believe me. All right, and also a trip to your local guitar store. For some folks, there's not a guitar shop that is conveniently nearby your location, and learning guitar maintenance skills are important to keep your guitar in top condition. All right, the G4V Workbench crew is here today. We have with us John DeMarco. Say hi, John, the lead off for the crew. And Leif Peterson, one of the helpers.
I don't know what I'm helping.
And Matthew Lorance is on a business trip, I believe. Is that what you said, John? He's out and about somewhere. You're muted, John.
He's traveling, I know that. But I think he might be on, but he's traveling.
All right. I don't think he is. I don't see him anywhere.
No,
Anyway.
I think he's iPhone 8.
He may be iPhone 8.
I think he may be iPhone 8.
Oh, he is. Chime in there, Matthew. Why don't you unmute, Matt? So we can see you somewhere in there. Let me change my prospectus here. All right. So anyway, and we have a very special guest with us, and he's special in more than one way, and I'm not talking about that. He's special because Robert Rosania, I can never pronounce his. Yeah, thank you. Was my very first student when I came into Guitar for Vets as an instructor.
Oh, he's special in many ways.
Yes, that's it. So, and he put up with me stumbling through my first lesson, or giving my first lessons. But Robert is an engineer, among other interesting. You're into physics and
physics, chemistry,
and
mechanical, technical, all of it.
So there's a bunch of talents that Mr. Robert has. And
Daniel, what you're trying to say for Robert is that all of life and artistic expression is within the reach of a true artist, something like that, right, Robert?
Sounds good.
Yeah, we'll go with that. All right. So Robert's going to be our first presenter tonight, and he has made a 3D print guitar, and I thought it was really interesting when he first showed it to me, and I had to connect him with the workbench so that we could show off this really cool thing and how he built it. So Robert, I'm going to let you go ahead. Wait, I have one more thing to say. Please bear in mind that everything that is talked about or demonstrated by the Workbench crew is based on the Workbench crew's experience, opinions, skills, and knowledge, which sometimes we got to wonder. Every effort is taken to verify any information put forth. Any references to brands is for demonstration purposes only, and the G4V Workbench has no affiliations with any of the brands that are mentioned. So, carry on with yourself, Robert. Thank you so much for showing up and helping us with this tonight. I'm really looking forward to hearing about this.
My pleasure. Thanks for having me. I'm going to try and figure out how to share again. There we go. I got a little PowerPoint going just to... I think you guys can see that, right?
Yep, all good.
All right, cool. Here we go. All right. So this is what I based it off of. Prusa is one of the many brands in the 3D printing world, I guess. And I came about this because I got to a point where I didn't really want to play guitar anymore, so I decided to build a guitar, and I had a 3D printer, and it got me back into tinkering with that. So I ended up getting a Stratocaster kit off of Amazon for about $80, and it came with the neck, the strings, the pickups, and all the electronics. And went through and printed some of the pieces. This is the main body of the guitar that holds the neck of the guitar here. Your electronics fit in here. I had to do some slight modifications because when they designed this Prusa was in Europe, so their uh, depths of the pickups was different, and all the hole placement for the neck was different. So that took a little bit to figure out and modify. These are just some of the 3D renderings of the files that I printed. Pick guard. This is where the tone control goes. You'll see a picture of it here in a second. This is the 3D printer I use. It's got a build plate of about 1 cubic foot, so 12 by 12 by 12. This the center section of the guitar I tried printing on my other printers, which had about an 8-inch build plate, and I just couldn't get it to behave, so I got a bigger printer, of course. This was printed out of a carbon fiber reinforced PLA. It has extra walls that you can see on here. Typically, there's only 2 or 3 walls. I think I did 11, if I'm not mistaken. So that's about 1/4 of an inch thick. And just another angle of it. You can see the infill here was, I think, at about 60 or 70%. So it's pretty strong. I wouldn't want to be hit with it. Just some different photos of the process of it being printed. Dry assembly, I put some copper tape in there to, I guess, try and do it right. More assembly pictures of it. And then finally it's all put together there. So my issue is I've been dealing with 3D printers for so long, so I'm sure you guys have questions about it, and that probably helped me tell you more about it.
Excellent. Thank you, Robert. Y'all can unmute and we can talk about this. And I know Leif has a million questions already, but really cool that I don't know if anybody noticed it, uses the 6-point tele bridge instead of the 3-point.
Yeah.
Which is a lot easier to adjust the intonations, and I'm sure that there must have been some issues with intonations and tension for sure. But Leif, I know you've got a million questions, so I'm gonna let you go at it.
Okay, so my first question is the little square holes, do they resonate? How much noise does it kick off? Because like, wasn't that one of like BB King's complaints? Is sometimes like on an electric, sometimes it makes too much noise. Like, how's it sound? Like, how does that sound? Do you have it there? Can you play it for us?
I do have it. It's probably not in tune. It's I don't know if it'll pick up on the screen.
You've got your background blur on.
But my action is probably 3/8 of an inch right now. So unfortunately, it's not very playable anymore.
Oh.
Well,
The
we were talking about latch steels here maybe a little bit later, so you could just pull the frets off and.
No, you gotta know where you're playing. So keep the frets on so you know where you are.
Oh, okay.
Yeah.
But yeah, after about a year of sitting, because for me, this was more of a project of how to build a guitar. And as Dan was mentioning, the setting up the annotation and just understanding the mechanics of it. Because I guess by trade, nature, whatever, I'm a mechanical engineer, so I need to know how things work. And it helped me dive into the mechanics of how the guitar works, how I can fix it, how I can fix the annotation, what everything does and how it all works together.
Yeah.
So
Where's the biggest flex point on the guitar? Is it here? Like where's it getting the most?
I think right in this area, I haven't
Okay.
taken it apart yet to inspect it because I knew I was going to be here talking about it, obviously. But my hunch is that it's pretty much right where it's bolting in to the neck. I believe it's starting to have a stress crack in there.
Okay.
And that's just because, I tried to leave it in tune for a year sitting on the wall.
I mean, it happens to a lot of other guitars too, That's a very common break. And I didn't know if there was some way if you would reinforce that or.
Well, so the nice thing about this, I call it a modular guitar, and I kind of glazed over that aspect, and it's hard to show, but there's M3 screws, and here. So I can put an Allen key in there and take off all the honeycomb, the purple area, the pick guard, and I can change it to any color I want. And there's filaments out there that are multicolor, multicolor. Hold on, I'll show you. There's my little Acatina.
Yeah, the Ocarina. Yeah, that's beautiful.
There you go.
Ocarina.
But this is like a chameleon filament. So, if I wanted a chameleon guitar tomorrow, I could arguably just print all the pieces and.
Oh, that's awesome. Yeah.
Completely different guitar. But I think that center part that I did out of carbon PLA, I'm going to try and instead of, I think the 11 walls I have, I'm probably going to do 20 or 30 walls and see where that brings me and try and make it almost a solid piece.
It'd be a clubber, man. Yeah.
And to go back and answer your.
How long does it take to print an individual part? Say the green area.
I'll get to that. I just wanted to answer the tone of it. For me, I didn't like the tone of it. It was very tinny.
Okay.
So it was bothering me that I didn't answer that.
Yeah. Was that tinny? Was that the pickups that came in the kit?
I think so.
Oh, okay. All right.
I talked to some people and they told me to put some resistors on the pots and all that, and I just never got to it.
Or you could just get Amy and Daniel could correct me, but if you get just like an equalizer, a graphics equalizer,
do the treble blade, it'd be easier.
There you go. Yeah. Okay.
And so to answer John's questions, depending on the piece, this part up here, it was a little section. It took maybe 2 hours. This purple part, I think, was about 4 to 6 hours. And the centerpiece with the walls that I had it designed at, I think that was about an 18-hour print.
Wow.
So the back of it, is that texture? It looked like a tree branch or like a mountain or something.
Which part?
Like there was a texture. I don't. Can you bring it? Are you
on the centerpiece you're talking about?
This thing right here.
Yeah.
Hang on, I can't. Yes, there's a couple of pieces that have some.
Yep. So that's the infill, and You have the walls, which
No,
is
no, there was it was, I think it was the back on your green piece.
the back and here.
Yes.
Oop.
Okay, so are those structural? Go back to the other one. Yeah. Is that vein that goes through the middle, is that a structural piece?
No, that was just I think I ran out of filament or I was
Okay, I see.
messing around with it and it just kind of looked neat.
Yeah,
It
it
goes
does.
from that purple to a green to a gold and
Yeah.
then repeats.
Okay, I see. I know what now I see what I'm looking at.
Yeah, and that was just I was playing with the a feature of being able to change the filament mid print, and now I can, with the printers that are out now, I can, you know, do it anything. I could put designs in there. I could put a G4V logo in the pick guard anywhere on it. It's pretty amazing where it's coming with the printers.
Awesome.
So talk to me about the pick guard, because I love the pattern you've got going on there. So did that come with the original plans or did you do something on your own?
So when you're going through the slicer program, so let me see if I can show you a little bit easier. I didn't have anything. So you'll take this part and you put it in a program that's called it's called a slicer, and that converts the 3D image into an STL file. And that's where you put the parameters in for what type of infill, how many walls, and what pattern you want to show on the pick guard. So like normally it looks like a piece of plastic here. And on the pick guard here, I don't remember what it was called, but it was just one of the different designs that you can do it, and it basically matches the outside shape of it, and it just gives you that pattern. I think it's like a concentric or something, but because it's a weird shape, it gives you those different lines to it. It
makes it dimensional.
Yeah. Here, let's see if I can get it to show better. No.
Yeah, your blur's on, so we can't really see it.
Yeah.
I guess the blur just looks for a face, huh?
Right.
There we go.
Yeah, very cool.
I like that. You could get like a mother of pearl look, I'm sure.
Yeah, and I printed pick guard out in orange and green and different colors, and it's a silk white, they call it. Came out like that. The green's a silk.
Does it have that like feel of a pick guard? I mean, it's just plastic, right?
Yeah, it's just plastic.
When you're saying the different PL whatever and all that, is that the grade of plastic that it is, or how does that work?
You could say that. So there's now probably 20 or 30 or probably 100 if I had to guess. I haven't been too far into the 3D printing industry as I'd like to be, but they have filaments out there that are as strong as steel. After you're done, they come out as plastic on your 3D printer, and you take it and you put it in the oven and get your wife angry at you for baking your plastic part. And you can make motors out of them, and you know there's a whole another aspect for 3D printing where people are building car parts and one-off throttle bodies and just pretty wild things. So you know, the problem with that is the filament I used for this, the carbon fiber PLA, was about $30 for 2 kilograms, or 1 kilogram. I'm sorry, 2 pounds. The stuff that turns into metal is about $200 for the same amount.
Wow.
So you want to make sure your machines are, in tip-top condition and not going to really waste anything that you don't need.
Right.
So
It's amazing.
and there's everything in between. You can print with ABS. There's PTEG, which is good for not down here in the sun, but in most other states where it doesn't beat you up too bad. You can make cell phone mounts in your car and different things like that. And as you would imagine, they all have different material properties.
It's crazy. I wonder if that's how they're building some of the graphite guitars. I'd like to look in to see how they're building the acoustic. Like Paul has one. Paul Lilly has one. If I ever come across one, I'd like to buy one. They really sound interesting.
Yeah.
That materials science is grown so much, because there's even materials light, phenolic natural fibers, and so man, you can make all sorts of stuff.
Right. It's getting pretty interesting.
You were talking about CNC, yeah. Between printing and CNC, yeah.
Right.
And if you have the combination of both, it's even more limitless on what you can do.
Well, we were just this past Saturday we did on Guitar Shop. We were talking about how technology has caught up to guitar amps, and with modeling amps and smart amps, smart apps. It's getting to where
you said to watch your language, Daniel. You told me.
Yeah, you little
language,
smart app, you.
And you're telling me.
So it's technology is catching up all around the music industry, and I'm sure it's not just with guitar playing. I mean, obviously it's rolling over into probably how orchestra instruments are made now. I'm sure there's the traditionalists with some of those, like violin, and basses and etc. But look at drums. I had a drummer that had a full electronic kit that was just amazing. And it was put out by Roland.
Yeah.
Of all people, making a drum. And so it's getting to where we're trying to take a look at go-arounds for wood, as far as building guitars go, because of sustainability. And I'm just amazed at what the different mediums that are being used to build stuff, build guitars.
Well, John's going to talk. Is if we have the time, John's going to talk about making a lap guitar, right?
Yeah,
I mean,
lap steel. Yeah.
With steel guitars, and I mean it's endless, really, because it's a noisemaker.
Yeah. Well, the interesting thing to me is I did a tour, and I should post it up on Cab Art sometime. I did a tour of the Taylor factory probably almost 10 years ago now. And the amount of CNC that they were using to make their raw parts. Now, what they were still doing, this is outside of San Diego, they were still assembling everything by hand, but all their parts were cut to the nth degree so that all they had to do was assemble.
The tolerance is almost perfect.
Right.
Mechanically perfect.
Well, and like I was watching this one guy, he was insetting rosettes, right? And when I do that, I've only made a couple of acoustic guitars, but when I inset a rosette, it takes me all evening to cut the channel and fit it and get it right. It takes me all evening. It's a nice evening, but he was probably doing 15 or 16 an hour.
Jeez.
Yeah.
Just,
Yeah.
because like you said, the tolerances are so close, just a little bit of tweaking and,
Snaps in.
yeah,
Yeah.
yeah, yeah. So yeah, it is
Amazing.
amazing. I have used the CNC a couple of times to make, electrics. And I am fascinated by my grandson
Yeah.
Robert has got a 3D printer. He makes me dragons, on it, and
I got a
How
little
old is your
strawberry
grandson?
dragon.
he's
There you
8.
go.
Yeah, and he's made that kind of stuff too, where the dragon is articulated. Yep, yep.
Yeah.
How old your grandson?
He's 8 years old.
Yeah, there you go.
Yeah, yeah, yeah. It's pretty humorous because to him it just works, right? You pull up the software, you find what you want to make, and away you go. And
Like
and he
trying
always
out
says to me, like,
tabs.
if I go over there, he'll say, "Well, now, pops, this one's going to take 2.5 hours. We should go do something." So
Oh, that's ice cream time.
yeah, yeah. But yeah, good stuff. Well, are you going to make another one, Robert, sometime? Do you think?
Um, so I've been looking at different things. As you've seen, I made the flute. I had to make this guy for the Strawberry Fest. We had a tent over there this year, and they told us we needed a strawberry to display. So Strawberry Dragon it was. But as far as making another guitar, there's some plans out there for actually an acoustic one. And I wanted to play around with different materials on that to see if I can get different tones out of it. Um, so I'm kind of in the research mode of it. But as you were talking about CNCs, I was talking with a local vet here in town that has every tool I want in his garage, CNC, a laser, all that. So we're talking about trying to make an electric or something. I don't know yet.
If you
Cool.
if you looked at ukuleles,
Yeah, but they're
so I
tiny.
love. I mean, I have a Waterman. I have a plastic ukulele.
Yeah. Oh, for to 3D print, they do have
Yeah.
ukuleles to print as well. That's probably more sensible to see
And then if you like
the
the electric,
tones.
they'll sell you if you want to make a electric ukulele. They've got a post, like a 4-post electric, pickup for a steel string, a ukulele if you wanted to print one. But yeah,
Yeah.
yeah, Patrick knows me and my ukuleles.
There is a traveling guitar. It can be acoustic and electric, if I remember right, John. The one where the bottom and top, they're more like a rest, and it's just the centerpiece.
Yeah.
Right, right.
And I'm not sure. Are they made out of graphite, or how are they made? Are they carbon
Well,
fiber, or they're not wood?
no, I've actually seen both. I think Yamaha's got one that's a travel guitar, a silent guitar. And I think the outside is wood on that one, but I've seen them with carbon fiber too. And because they're travel, that would make sense because carbon fiber is so much lighter than almost
Yeah.
anything, with any structural, um, integrity. But
So the way to make the strength of that one block that's taking all that tension is merely by changing the layers and where
The
those
parameter.
layers are.
Yes.
Is that how that works?
Exactly. 'Cause you have the walls that build it, and then the top and the bottom. So you're able to choose how many walls. Something like the dragons, they have 1, 2 walls, just enough to get the color to be consistent. But then when you're doing structural things, you can do
You can
infinite walls
you
and
can
just make it
change
a
the
top.
so you changing the density. Is that what the?
Exactly. There you go. That's the word I'm looking for.
That's interesting. So you can almost, if it was 100% solid, how much would that piece of cost then?
Um, so the way it's built right now, and it's probably about 90% full, 80% full with all the plastic in there. I think I used about a half a roll of filament, so that was about
So that's
$15, so about $30 maybe. I'd probably have some filament left over for something else.
gotcha.
what's the end guitar weigh? Because I know 7 pounds sometimes. I don't want to be a complainer.
Well,
But
give me 1 second. I'll get a scale.
I'm sure it's mostly the weight is in the neck or
Right.
any of the metal parts.
Yeah.
do a bit of a dive and see which direction it goes.
Right, right.
I wonder how much 3D printing you could do on a neck. Like, John, would you have to do like carbon fiber, like doing some rotating pieces inside, like along the?
That'd be
Oh,
interesting.
Yeah, I structurally, I don't know if you. Well, you could. I mean, you just have a lot more material in there, I guess.
Yeah, or like just a 5-piece glued. So it goes in all different directions.
Am I right about 6 3/4 pounds?
Wow.
That's
Okay.
not bad. That's not bad.
It's not bad at all.
But more than I would have thought. I would have thought
Yeah.
more 4 or 5 pounds.
Oh, I was worried it was going to be like an 8 or 9 pound.
No,
I was sitting there
it's
going,
not a Les Paul.
get a bass strap.
Yeah, I was going to say
Yeah,
it's
yeah.
a lot lighter than a Les Paul. That's for sure.
Yeah.
Well, Robert, thank you so much, man. That was, I mean, I just think it's fascinating of where the direction of technology is taking us as musicians and playing these instruments, of what it's doing to change. Whether it's an improvement is another story.
Right.
I mean, like some of us that have been around that have experience with the old tube amps, like the one behind me, are used to not having to deal with, you get a stomp pedal and it's got 2 knobs on it, so you can play with the knobs and know what's going on, and you know how to set your tones. But now with modeling and the smart amps, and then with guitars being built differently, and I've seen now they're putting electronics into the guitars, and it's just crazy, like Leif's little kill switch. So anyway, for those of us that are also into playing alternative instruments, that's just kill switch. And John is going to talk about one of the oldest instruments, guitar instruments that they've been, and that's a laptop guitar.
Yep, lap steel guitar. Hopefully you can all see my shared desktop now. So I've got a little video here, and just to preface this week, the next time we get together, I'll have the actual build for you to take a look at. This is more how I went about trying to figure out what I wanted to build from a lap steel guitar. Then I have to learn how to play it once I finish making it. But it's pretty easy concept, and we'll talk about that in a minute. But I'm also going to show you how I sort of copied or designed it from some other lap steels that I saw out there on the web. So we'll just jump into it here. And, they come in all shapes and sizes, right? You get the kind of the Hawaiian ones, which look more guitar shaped. What they all have in common is the fact there's an 8-string on the left-hand side there, is that the strings never touch the frets. In fact, most of the time, especially on the less expensive ones, the frets are actually painted on, basically. I'm just going to pause on this one for a second here, because you got 2 very simple lap steels that can be built, and originally I was just going to do that and show that to you, but what we have here is basically a lap steel built out of a 2x4. The one on the left there is a kit you can get from CB Giddy, and they give you the electronics, which is literally a plug, and you wire it directly to the, in this case, a humbucker, and they give you the bridge and the nut, and then a bunch of these ties that you put on the 2x4 to show you where your frets are. I'm not quite sure how you calculate where they belong, but in any case, the one on the right is, again, a kind of 2x4 version of it, but it's made by, it was actually a book written by a guy by the name of Martin Cook, who out of Germany. And you can see a very simple, he's got a volume and that's it. I'll keep moving here. And, I looked at that and I decided, well, that's not quite as much fun as it could be. Well, now here's somebody, they build a lap steel out of a skateboard. I thought that was kind of interesting. Nice challenge there. I like it. Here's what your typical, lap steel looks like. You go out on the line and there's a bunch of companies that have got these kind of, triangular shaped ones. They didn't really give me a lot to think about, but they're interesting. And here's where I really found myself enjoying it, and that is kind of an Art Deco look. And I just kind of like that pyramidal look that you see there. The show bud is in the middle there. That's about a $3,000 laptop or lap steel. The other ones that you see here are a little less expensive, although the National on the right-hand corner is pretty old. So from an antique standpoint, I think it's up there around a couple $1,000 too. I'll move on here to the next slide. Here's where I kind of went, hey, I really like the look of this. And this is a company called Duesenberg, and literally out of Europe. And I liked kind of the profile that they have on this guitar. And again, it's kind of an Art Deco look, and I kind of like that. One interesting thing on their higher end, and these are $3,000 to $4,000, I guess, is they've actually got a little, trench in the middle of the fretboard there, and they can actually move the nut up and down, so they can get different tunings, different keys by moving it just like you would a capo. I also copied in, what they said the dimensions, the rough dimensions are for this particular guitar, and that was kind of my starting point if I want to build something that looks sort of similar to that. And then when I move on here to the next slide, I'll just take a second here. Here we go. Now we got my, I always do research, right? So statistics and specifications, I won't read this whole thing to you. But, the interesting thing to me is the scale length is anywhere from 22.5 to actually 25.5. I should say 25.5, not 24.5. So everything from shorter, much shorter than what we're used to. I think a Gibson is usually 24 3/4, and PRS is a 25-inch, and then I think Fender is 25.5-inch for scale length. So it's all over the place. Nut widths, they're much larger than the average electric guitar. Body width, anywhere from 6 to 7.5 inches. It's kind of interesting. There's people who have a lot to say about scale length and the tone that you get out of it. String height, 1/2 inch to 3/8 of an inch above the fretboard. Like I said, a lot of them don't even have actually frets. They're just markings. And then, of course, there's all different kinds of profiles and shapes. They make them out of most body materials that you'd be familiar with: mahogany, ash, maple, any kind of dense wood probably works pretty well. And then we're going to move on to, okay, how did John go about, creating his plan? Because I think you guys know from our last time we got together, I like to create a full-size, at least of the body, but I like to make a full-size template that I work from when I'm building this by hand. So again, I'm in my free software that you can all get, Affinity. And I'm creating a document in millimeters because I've decided I'm moving to millimeters. And it's 1,000 millimeters wide by 250 tall. I took a picture out of the web, and I sticking my guitar that I liked out here as my first layer in the document. And once I get it situated the way I like it, I'm going to go over and get the measure tool and yep, and I'm going to measure the nut, because what I'm after at this point is that 65 millimeters, which is a little fat for what the final is going to be, but I wanted to get as close to 65 millimeters, which essentially puts this photo into the same scale, almost the same scale as what I saw online. The interesting thing when you steal a photo to kind of create a template like this is if you're at a higher angle or a lower angle, you get some distortion, and so you might foreshorten the picture, but it gets you in the ballpark. And I've made a lot of bodies this way by taking a picture of a body and then putting it in here to create my drawing. So now I'm going to go over and start using something that they call that's the pencil tool. That's wrong. I'm going to use the measuring tool here first to check the length. So now I'm making sure I'm in the neighborhood of the length that I wanted. Again, all in millimeters, which was fun because I'm an American. I don't think in millimeters very often, but gives me an idea if we're in the right ballpark. And then eventually I'm going to start tracing this using something called the pen tool. And that'll start in just a second here. And it's a tool that I learned to use when I was using Photoshop back in the day. And I, in a former life, before I was a database geek and a marketing online geek at the company I work for, I was a photographer. And so Photoshop is another one of my pet things. I like to mess around in Photoshop, but nowadays I'm using Affinity because it's free. I don't have to pay the subscription rates. So, a lot of the detail work, it seems to be that you want to get a headstock you like. And so you can see what I'm doing here is I'm starting to outline the headstock with this pen tool. And I'm not being very careful about it. And the reason I wanted to do that is that people always think this tool is very, very hard to use. The reality when I used to teach Photoshop back in the day is, you don't want to try to get perfection on the first time you go around whatever you're trying to outline. And of course, you can do this with artificial intelligence now, and it can automatically outline things probably faster than I can. And then you just make some corrections eventually. But you can see what I'm doing here. I'm just outlining this thing, getting the basic profile, but not really caring how perfect this is, because I'm going to go back in, and you'll see that in a minute, and I'm going to fix all my curves. So sorry, I should have sped this up, but we're almost all the way around. All right. So now there's my original, lines that I did pretty quickly. And in a minute here, we'll, and so you can see there's my outline, right, that I made. Again, kind of sloppy, right? A lot of squared off edges. There's not anything too round about it. But we'll get to that in a minute too, because I kind of decided to do a little bit of a more squarish on some parts and a little more rounded on some parts, and we'll see that in just a minute here. But now you can see I'm using that pen tool. I'm creating some more dots, and now I'm really getting in tight to where I want it to be. And to me, one of the things that people always look at is the headstock. There's some interesting things going on right now. Leo Fender, he only ever copyrighted and he patented his guitars, but he only copyrighted the headstock. He didn't do any kind of a copyright on his body shapes. And whoever the current owners of Fender are right now, they won a court case in Dusseldorf, Germany, and now they're going around and they're starting to bully all the small boutique makers who are making S-style guitars. They haven't gotten quite the guts to go after the big guys, the Ibanez and others who are making S-style guitars. And I kind of wonder if they're really ever going to do that because, the body shape's been out there for 75 years and never been copyrighted. In any case, I just go around and I kind of, get it so it's fitting better. I'm getting all the, and I can change the angles and move my anchor points and that kind of thing. And this is something that, I don't know if anybody's interested, but, was a program Adobe had called Adobe Illustrator. Essentially, Affinity here is a combination of Affinity and Illustrator. So you can work on photos and you can work on, creating these Bezier curves is what they're called, all at the same time in the same program. So, So, that was my first, shot at, well, okay, this is kind of the profile I'm after. And then after I looked at it for a while and I cleaned it up a little bit more, I decided, I really kind of like that Art Deco look. And so as we're getting near the end here, you're going to see that I put in, okay, here's where my fretboard's going to be. And here's where my bridge is going to be. And that was carefully measured by using the measure tool to put it in the right place. And then after straightening out a few more lines, I decided, you know what, I like this, but I want to make it a little bit different. I want to make it a little more Art Deco. And so I fiddled around, added a few more lines, and eventually what wound up happening is I got to this. And so you can see I've got that kind of a pillar headstock now, and I probably will do something a little fancy up there. I'm going to back that up just a little bit and hit pause. And then I'm sure it's coming again. Here we go. There we go. And then I decided that, well, I like that, but I also want to add some depth to this. So the gray area that you see here, this will be a step up. So there'll actually be a piece of decorative wood that's like a pillar, right, coming up here. So I'll actually have 3 layers. I'll have the base layer that I'm going to make out of a step, a piece of wood that was meant to be a step. And then I'm going to have, a piece of wood that the fretboard will go on. And I'm not sure if I'm going to draw that on or if I'll actually, fret a piece of wood. And then I'll have a level of wood that goes up another little step to give it another 3-dimensional thing. And then on the headstock, this pillar. So that's my design concept for the lap steel. And again, you'll see that I've still got some curves on the sides, and that kind of echoes the curve here. But the rest of it has got some straight edges and some squared edges, and that kind of fits in with the motif up here. So next time, you'll see the build.
Thank you, John. Sorry, I had myself muted. I like that Affinity. I'm going to have to try and play with that.
Well, it's free. They just want your email address, and then you get some.
Everybody loves free.
Yeah.
I got this to, let's see if hopefully I can bring it up. There it is. And that's mine. That's the one I have.
I love it.
Yeah. $100.
Mm-hmm.
And there's that lipstick pickup.
Yep. Well, so that's my goal here is I'm using all recycled wood, probably recycled tuners, and then I've got a P90 pickup that I'll use. I might break down and put a pot on there for volume. I don't know if I'll do it for tone or not, but keep it simple.
Right. Yeah. That's what they look like. Just, looks like it's so easy to make one up. So we're actually at the end of tonight already. We're done. Or, for lack of a better word, I guess, done. Our hour is up. I really appreciate everybody helping out today. Again, Robert, thank you so much for your presentation. John, as usual, yours. And what happened to Leif? I think we lost him. He seemed to have some...
He messaged the chat, said the kids were wanting to go to bed.
Oh, baby
okay.
things.
Yeah.
And let's see here what I'm doing. Bring up. So anyway, again, thank you all. G4V is a 501c3 nonprofit dedicated to providing relief to struggling veterans through the healing power of music and community. Since 2007, Guitar for Vets has served at-risk United States veterans impacted by PTSD or other service-related trauma through our unique 10-week structured program, putting the healing power of music in the hands of our nation's heroes, helping to foster renewal, connection, and community.